The comparator. This is one of the most uncomprehended items in Redstone and in the game, but one of the most complex and useful items in the game, so I decided to make a video about it. This is Big Brother 161 and welcome to this channel and this video where we will talk about some of its properties, so let's begin. Now, this is the real version, which is 16 times smaller but a lot more useful. Now, this is the crafting recipe, which just requires 3 stone, 3 torches and 1 quartz. As you know, redstone signal starts with maximum power 15, coming from a source, and block by block is losing 1 point of power, until eventually the signal is 0. One way to continue with this signal is using repeaters. And for a long time, the only function power levers had is to determine how long a redstone signal gets. But this changed when the comparator arrived to Minecraft. The repeater, when receiving any signal above 0, emits the maximum power redstone signal, 15. Nonetheless, the comparator projects the same signal power in its out terminal. The comparator, unlike the repeater, has a delay of 1 tick. As we saw earlier, 1 tick is a tenth of a second. As we can see on these 2 lines, the signal travels at the same speed, as long as the set position of the repeaters is 1 tick. The comparator emits the signal only to a distance, and as we can see in this example, we can propagate the signal using this setup: comparator, block, redstone, comparator, block, redstone. And that way we can keep that signal power up to a long distance. We can see in the in it's 12, and at the end of the line is also 12. At the end, 13. So we have this setup where we don't need to have a comparator in each block. So this is a lot cheaper. To explain in a better way, the comparators have 4 possible connections. In the back part is the in, the forward part is out, and in its sides you can see the auxiliary connections. Now, its main function is the comparator mode, where we will connect the in position and one of the auxiliaries. Now, in this experiment, the comparator is receiving a signal power of 12, and for the first part in the auxiliary is going to receive a signal power of 9. 9 is lower than 12. So in this case you will see that the out position is going to be positive, the same level power as the in position. In the second case we're going to see the auxiliary position is receiving the same signal power as the in position, and the comparator is going to emit the same signal. In the third case, we're going to receive in the auxiliary position a power signal that is greater than the in position, 14, 12. So the comparator goes off and emits no signal. And that is its function. As you can see here, where it says mode, it's in comparator mode. With right click, we're going to pass it to subtract mode. So let's repeat the same experiment. We have 12 on the in the auxiliary position is receiving 9, so the in position is greater than the auxiliary. But in this case, the subtract mode does the following: 12 minus 9 is equal to 3. Now in the second case, remember the auxiliary is receiving the same signal power as the in. 12 minus 12 is equal to 0. The same occurs when the auxiliary is receiving a greater signal power than the in. 12 minus 14, so the out is 0. The next function of the comparator is probably the most used one. So if we have a comparator placed this way with a tile entity in its in connection, in the first case we have a chest that is empty, so the signal is 0. So what happens if we place an item? Well, the power signal is 1. But if we fill it up to a third, then we have 5, a third of the signal power. And if we have a full chest, then we will have a full signal, 15. And of course we have this function where we can have a full block between the tile entity and the comparator. This allows us to read a signal through a wall. Not only can we do this with chests, we can do it through trap chest, dispensers, droppers, hoppers, furnace, blast furnace, smoker, barrel. Now let's remember that if we place on the detector rail a container minecart, it will emit a full signal in its presence and it will emit 0 signal in its absence. But if we do this with a comparator, what it will do is read how full the container minecart is. One item emits 1 of power, 1/3 full emits a power of 5, and completely full is going to emit the maximum power. Now, other tile entities comparators can read a signal from are the brewing stand, we can fill up a furnace, an end portal frame, a cauldron, we have cakes from which the comparator is going to read the different levels, we have the jukebox where every disc is going to have its own power signal, the lectern where we can change the page which we are reading, and the comparator is going to read what proportion of the book we are in. The last function I want to talk about is the selector mode. If we place an item in an item frame this way, I prefer to use an arrow, the comparator is going to interpret in what position that item is in. With right click, we can place the item in 8 different positions, and the comparator is going to determine in which position it is. So of course you can use any item you like, for example an ender pearl, but that's a circle, but I prefer to use an arrow because it points out the position you are in. For example, you have it in the first position, the out power is 1, now in the third position, the power is 3, in the sixth position, you can see the power is 6, and if we go to the maximum position 8, the out power is also going to be 8. After that, it just returns to the first position. Now in this last part, I'm going to show you some of the most basic circuits we can build using comparators. Our first circuit is the 2-tick clock, where we can place this comparator on subtract mode and the outside is directly connected to the auxiliary. What is going to happen is this comparator is going to receive a full signal and the out signal is going to return to its auxiliary, making it subtract the signal power. The out is going to be 15, this one is going to be 14, then it's going to receive 13. Then we have 15 minus 13 is going to emit 2. Not enough power to reach the dispenser. This way we have a pretty fast clock. And this clock may be turned off, just hitting the source of power, or taking out the subtract mode. Circuit number 2 is a pulse extender. We have this problem where we need to open this door with this button, but the pulse duration is too low. It's only 1 second long. So this circuit is useful to extend the pulse. Here we can hit the button, then it turns off. But the pulse extender continues the signal. Now we can make modifications to the circuit. For example, in the outside of one of the comparators, we can place a full block instead of a redstone dust. What happens is that in this side there is no 2-step redstone dust where signal can drop a level, as you can see on this side. And that way the pulse duration is greater. An obvious way to further extend the pulse duration is to make this comparator loop longer. So instead of just using 2 comparators, we're going to use 4. Our third circuit is the automatic dispenser. Here the comparator is reading what are the contents of the dispenser. In the outside I placed a repeater which will increase the power signal, and then the signal returns to the auxiliary position of the comparator, which is in subtract mode, so it will be turned off. And the same signal returns to this target block which is feeding the dispenser. So if we place some items in this hopper which is feeding the dispenser, then the circuit will be activated. So any content you place in the dispenser will be automatically dispensed. For example, you can make a trash can. Circuit number 4 is the 8th position selector. Here you can see we have the selector we explained earlier, and this item is pointing on position number 2. So the second redstone lamp is the one that is turned on. Fourth position, the fourth lamp is the one turning on. On position 7 is the 7th one. Position number 8 is the last one. Of course, these out signals don't have to be lamps, it can be dispensers or any gadget you want to activate it with a selector. The circuit is actually quite simple, and seen from above you can see how it can be assembled. Just remember this comparator has to be on subtract mode. Our 5th circuit is going to be one of the most useful, and probably the most used one, is the item filter. Maybe you find yourself in the situation where you went out and all the items you collect are displayed here. So you come here and you want it to be stored on your storing system, but not every item has the same value, and you want to sort out the most valuable ones, for example these diamonds. So under this hopper line, you want to place 2 additional hoppers facing on these directions. From the first hopper, you want to place this comparator which is reading it, then these 2 pieces of redstone. This redstone is going to power this block, the block is going to power the repeater, then the repeater fits in another block which has this redstone torch, which is just under the second hopper. But on the first hopper you're going to configure its item displayed thus following way. The first item is going to be the item you want to sort out, followed out by other items that are going to serve as fillers. Here we can count 22 items. But what happens to the comparator when it detects 23? The power emitting from the comparator is going to turn into 2. So this last redstone piece is going to turn on. Of course, the only items that are going to enter this hopper is going to be the filter item and the filler item. Here I've placed sticks, but of course you can take these items and name them differently on an anvil. If we hit the lever and these items start to flow toward the sorting system, so what the circuit does is that the diamonds have been separated and any other item has been sent to the bulk storage system. These have just been some examples of circuits that can be built with comparators. But actually, there are many others. Just remember that Redstone is an entire world. This has been Big Power 161, and remember, I will be watching.